Bismillahirrahmanirrahim. We have our 11th lab that is basically related to chapter 11 of Chang book, that is data exploration, or we can say it spatial data exploration or GIS data exploration. Now this chapter is very important because when we have acquired data from multiple sources, the next phase is to perform meaningful analysis on these data sets. For example, I have point data of schools in a city, and I have road network data of that particular city. Now I wanted to see which schools they are within uh, 0.5 kilometer or within 1 kilometer of the road. So I can perform my analysis using GIS queries, select by location or select by attribute, etc. So that is very important in GIS, that we learn how to explore our data set. Now, for this chapter, I will recommend you to read this chapter, that is chapter number 11, data exploration. Now, in this chapter, you will see that you will have attribute data queries, spatial data queries, raster data queries, and map based data manipulation. Now, it will show you some theory about what is data exploration, basically data visualization, then descriptive statistics, and then you will have graphics and how to attribute a data query, and how to perform an SQL statement, how to perform some relational databases query, right? So these if you read this chapter, or if you go to through the theory, you will have some basic concepts that are important and related to data exploration, and similarly how to perform a raster data query. So in this exercise today we will focus on practically performing all these concepts using the task mentioned in this book in ArcMap. So we will now focus on the practical section of the data exploration techniques, that are applications, right? So that for that purpose we will perform these tasks. I will explain you one by one. Select features by location. If you have some shapefiles and you want to select those shapefile based on certain location, and you can select your features by graphics or by drawing a circle, etc. Then if you have 2 to 3 multiple data sources and you want to join them and then perform query that is related to two tables, for like I gave you an example, you have a separate road file and a separate city school files, and you want to query data from based on two shape files. So you can perform a join operation or a relate operation, and you can relate different tables, etc. And similarly, one important concept is raster data query. If you have a raster data set, you have a dem, you have an aspect, you have a slope, and you want to perform some query on a raster data set, so you can actually perform you combine the spatial attribute data, and then you can perform the queries on the raster data set, right? So this is the timeline of our today's lab, and then we will be finally concluding our lab session. So now we will start one by one explaining the each task and performing them practically in ArcMap. Okay, I have opened my chapter 11 tutorial from the Chang book, and I have my ArcMap open, right? Now we will perform this lab, right? The first task is to select the features by using location, right? So in this tutorial, in this task, we have two data sets that are id cities.shp and snowsites.shp, right? So we will, as a first step, we will add these two data sets in ArcMap. So now I will open my ArcMap, and I will go to layers and click on add data, and I will select one is id cities.shp from here, and the next file I will add from here is my snowsites.shp, right? Now you can see that I have added two data set, one is snowsite and one is id cities. Now let's change the symbol of snowsite to green so that I can visualize where my snow sites are. So these are my snow sites displayed over here, and these are my ID cities data, right, displayed over here. Now these are two different shape files, right? So let's perform some query which are mentioned in the tutorial. So in this tutorial basically you have to first of all, from ID cities we are only interested in Sun Valley, city named as Sun Valley, right? So we have to select by attribute. Now for select by attribute you have two options. First one is to go to attribute table, and here you can select by attributes. Now in this select by attribute you will type the city name, equals to, you will click get unique values, and here you will have somewhere Sun Valley. Here it is, Sun Valley. So you can verify your query and click apply. Now you will see that only one record has been selected, that the city name is Sun Valley, right? You can close it and you can see the highlighted here your ID city is Sun Valley, right? So we have selected the Sun Valley from our cities, right? Next we want to see that which snow courses are within 40 miles of Sun Valley, right? So you can go to selection. Here you can select by attribute and select by location. This is the second method of selecting by attribute. Now if you go to select by location and you want to select from currently selected features, okay, here it is, in select features from, we have snow sites, and in source layer we have ID cities. Now are within the distance of the source layer, right? And you can specify here, let's suppose 40, and in units you have to specify miles. Now this select by location query we have rightly now generated will select all those snow sites that are within the 40 miles of ID cities. I hope it is now clear that it will select all those snow sites that are within 40 miles of ID cities. You have to click it apply and OK. Now if you go to snow site, and you will see that 200 snow sites, they are actually selected from this snow site table, and 200 records they are selected. So now you can actually show these records here. You will have a highlighted section, right? So this is a method how to perform query on based on two different shape files. So this is our first task, that is to select records that are within 40 miles of the Sun Valley. So first of all we have selected Sun Valley from the attribute table by using select by attributes of ID cities, and in the next query based on Sun Valley selected site we have specified that which snow sites are within 40 miles of that Sun Valley site, right? So this is basically how to perform an attribute query. Now the second task related to this task is to generate a graph. Generating a graph is very simple. If you go to attribute table, you just have to select create graph, and in create graph option, here you have to select your X field and Y field. For example, in X field I want to select SWE maximum, and here snow sites, and I want to map, for example, elevation. Now here elevation is mapped across SWE maximum, right? So similarly you can change the left and right index and click next and click finish, so your graph will be generated. So you can change the different data sets, and you can change the X and Y columns and generate different data sets. So this is our first task, that is to simply query based on two shape files. Okay, now in task 2 we have to perform selection, and that selection is basically select feature by graphics, right? So what you have to do basically is to select Sun Valley from ID cities that we have selected, and then by select by circle we have to draw a 40 mile circle, that is basically graphics illustration, right? So this is our simple second task. For example, if I want to uncheck this, and here my sun valley was actually selected earlier. Now if you go to select features, right, here you have option select by circle, right? So you can actually click here and you can draw some circle, right? So it will highlight all those snow sites that are within the circle you want to draw. Here another option is to use select by graphics. This option is not working with me. If you have this option, you can actually use that one as well. Okay, the next task is task 3. In this task, you have to basically query and join operation you have to perform, right? I will remove all these layers now. Now here in this task you have to add wp.shp and wp-data.dbf file. Okay, I will add here data wp.shp, and the next is wp-data.dbf. So here one is shapefile and one is now some CSV file or some Excel file, or which you have a table file, or from any database you have gathered some data. So this table, it actually shows you certain columns, right, and certain fields, right? And here you have a shapefile. This shapefile is of cities, right? You can see that, and it's in attribute table. You can see that it has acres, ID, etc. Right? Now we want to perform a query which is based on a shapefile and a database or CSV Excel file or some any data source, right? These two data sources will be joined with one another using join or relate operation, and then we'll perform a query that is based on these two. Okay, first of all we have to click WP and we have to join it, right? And we have to join it by using ID with WP data, right? So click WP, join and relate, and click join, and you have to actually join it with ID with WP data and click validate join. Okay, here it is. Keep all records, ID, join attributes from table, and click OK. And now you click on the attribute table. Okay, earlier we had only these records. Now after performing the join, we have so many records, so many columns that are actually added from WP data, this CSV or a DBF file, right? Okay, the next task what we have to do is to basically perform a query now, and that query is basically WP data dot origin, it should be greater than 0, and WP data dot origin is less than 1900. I am simply copying this query in here and go to select by attributes and paste this query. You can actually type this query here as well, and let's suppose verify it. It was verified. Now click apply. Okay, here 175 records out of 856 they are selected, which basically determine that origin is greater than 0 and less than 1900. So this is some origin field over here. Here it is. Now in these they are 0 and 1900 that records they are selected. So this data is actually selected. If you want that I want only this data, selected data, to be exported, you simply have to go to data, click on export data, and save it as a shapefile, and click save. For example, in desktop I want to save, and click OK. So your data will be exported. Now this is the only record that satisfies that query. So this is basically our task 3, that was simply to use a shapefile, WP, and a database, that is wp-data.dbf, and perform a query, and as a result we have exported the selected results. Okay, for task 4 we actually need to perform a query attribute from a relational database. In task 4 we have soils, components, co-plants, and common file, right? So I will remove this data and add here these data sets one by one. More soils, you can press the control and add all the data that is required. Okay, by pressing the control I have added all the data, and here it is. Now in this task what you have been asked to do is to perform a query that will relate this shapefile with this first database common, and then it will relate or join common with coplant, and then it will relate or join coplant with components, and then it will perform a query that is basically a type of complex query in which you are relating 3 to 4 tables or database, right? So the common concept or the basic concept in this is to relate more than two tables with one another and perform a query, right? So you have to first of all relate most soils using mu key. Here I will press relate using mu key. Okay, I will relate it with component first. Component using mu key. So I will rename it as soil component, right? So my first shapefile is related with this fourth component using mu key. I have related. Now the next is to basically relate complant, right, component to coplant. Okay, here go to component and relate it with coplant using co key and name it as coplant component. Okay, the next is to relate component with commonth. Component, go to relate and with commonth using co key. Here we have co key somewhere. Here it is. So I will rename it as component commonth. Now you can see that I have related this shapefile with component, and then I have related component with coplant, and then I have related component with commonth. So my all these four data sets, they are actually now interrelated. Right now we want to perform certain query, and we can perform that. For example, here flood frequency is frequent or flood frequency is occasional, right? So I can perform this by using open attribute table here. Okay, I have to go to commonth and select by attribute. Select by attribute and flood frequency equals to frequent or flood frequency equals to occasional. Let's verify the query and click apply. Okay, 40 records they have been selected, right, from this query. So this is basically joining multiple tables and then extracting some data from here. So these 40 records, they are actually telling you where flood is basically occasional or flood frequency is frequent, and based on the relates. So this, okay, for task 5 we have to combine spatial and attribute data queries. Now this task is very important and useful in GIS. In this task we have to basically combine spatial and attribute data queries. We have two data sets, one is thermal.shp and idroads.shp. So first of all we will remove these data sets and add these two, thermal.shp, and the second data set is idroads.shp. So you can see that we have some thermal sites or some data set that is named as thermal, in which some wells locations they are basically given and their temperature is given. And then we have a road data set. So what we have to do is to basically use select by location and to select all those wells that are within 2 miles of the roads, right? So within 2 miles of the road we have to go to selection, select by location. We have to select all those wells that are within 2 miles of roads, right? I hope this query is now clear. Select all those wells or thermal which are within 2 miles of roads and click apply and click OK. Now here you can see that some of the records they are basically selected, and these are 405 records out of 899 basically selected from here. Now next is I want to select those wells from this selection which have a temperature greater than 60 and they have a type S and temperature greater than 60. So what I have to do is to go to ID roads or simply go to select by attributes from here, and in the method you have to select from current selection, right? And you have to paste your query here, and let's verify this query. Okay, here was some error. Type is S and temperature should be greater than or equal to 60. So you can type equals to S and temperature should be greater than or equal to, you will select 60 and now click verify. Okay, it was verified. Important thing to note is you have to select from the current selection. You have to click verify and click OK and apply OK. From those selection our record has been filtered to only these sites, right? So that is actually we have filtered our record based on our criteria. So I will repeat, that is very important. So if you understand this, you can perform some complex queries as well. First of all, I have two data set, one is thermal and one is roads. I have selected only those wells which are within 2 miles of the road using select by location, and from those selection then I have filtered my data that I want only those which have type is S and temperature is greater than or 60. So I have got, as a result I have got only these few sites, right? So this is our task that is related to performing the attribute query and the spatial query on two data sets. Okay, for the next task, that is basically how to query a raster data. We have two data set, one is slope and one is aspect, right? So we have removed this and add our slope and aspect layer. Here we have a slope layer, you can see it, and we have an aspect layer. Okay, if you change the symbology of your aspect and slope so that your layers they are now different. So here my slope layer and here is my aspect layer, right? So I have two layers added. Now what I have to do is to for querying a raster data set, right, we have to go to raster calculator. So a simple way to go to raster calculator is to use this search window, and here you just have to type raster calculator, press enter. So here we have raster calculator. Now in this raster calculator you can type certain queries. For example, here I want my query that from slope, right there, I want only those values which are equal to 2, and from the aspect I want values which are equal to 4, right? So this is my query, and what it basically will do is it will select values from slope equal to 2 and where aspect is equal to 4. It will combine them, these two, into some output raster. Okay, here it is. and click OK. Once you click OK, the operation will be running here. When the process is completed, so based on the criteria you have specified, it will give you output, right? Is in form of 0 and 1. I think 1 will be satisfying your criteria. So this is how to perform or how to query raster dataset. After performing the raster dataset query, you can now perform other operations. For example, in the challenge task, you have been asked to perform a new query that is basically population minus 2000, population minus 1990 population, multiply by 100, divide by this. So these type of queries now can be performed, right? If you have some vector data set, for example, here I have this file, soils file. You can simply go to any vector file and simply add a field. For example, let's suppose ABC and its type is integer and click OK. Now in that field you have to go to field calculator, and in field calculator you can perform simple. For example, here I want mu key divided by this one multiplied by shape, for example. So it will actually perform that query based on the data set, right? You have to go to field calculator, and for example I want mu key, okay, here mu key divided by mu sim. Okay, here some values are populated. This is just for example, so you can populate some logical expression by creating a new field and finding some new values. For example, you want to find some density, you want to find some percentages, etc. So this is all for today's lab. Now I will just give a quick revision. We have selected features using attribute, we have selected features using location, we have joined and related 2 to 3 different databases, and then we have queried them. Similarly, we have queried a raster dataset as well, and similarly in one of the shapefile of thermal and ID roads, we have performed the spatial and attribute data all together. So this is basically chapter 11, that is spatial data exploration, and we have created graphs as well from by going to the attribute table and creating the graph and specifying the vertical axis and the horizontal axis. So this is all for today's lab. Thank you. I hope now these concepts are clear and you will be able now to perform spatial data exploration techniques. Thank you.